All right, here is a subtraction problem where we're subtracting our two big fractions, our two rational expressions. Now, addition and subtraction, I need a common denominator. And when I look, I definitely do not have a common denominator. And these really don't look much alike at all. But what I need to make sure that I do is I have to factor my denominators completely to make sure that I'm not duplicating factors down there. Okay, and let's see what I'm talking about here. So this first rational expression is x plus 1, and to factor the denominator, this is the difference of two squares, right? Man, they love this problem. Difference of two squares, x and x, plus and minus, 3 and 3, right? The conjugates, x plus 3, x minus 3. Now, how do I factor the denominator on the right? Numerator is 5. How do I factor this, 4x minus 12? Well, look for a GCF, right? It's in order, look for a GCF. What's the greatest common factor? What goes into 4x that also goes into 12? A 4. Divide that 4 out, and I will be left with x minus 3. So usually when you see this rational expression, they are going to share a common factor, okay? Which means that you don't need to duplicate it. I'm going to ask myself, what does this rational expression on the left need that the one on the right has to make a common denominator, right? And it's missing a 4. So on the left, I'm going to need to multiply times 4 over 4. Now on the right, what is this denominator missing that this one had? Well, it's got the x minus 3, but it needs an x plus 3. So the fraction on the right, I'm going to multiply x plus 3 over x plus 3. Okay, now my denominators will be the same. Okay, this one, they're in different orders, right? I can just switch these two around, but they are the same. So let's do it. Let's put them together. The fraction on the left is going to be 4 times x plus 1 all over 4 times x plus 3 times x minus 3 minus, and the fraction on the right now is going to be 5 times x plus 3 all over 4, and I'm going to put this denominator in the same order as this denominator. X plus 3, x minus 3. Now that my denominators are the same, I can put them together all over one denominator. So it's going to be 4 times x plus 3 times x minus 3. And my numerator is going to be 4 times x plus 1 minus 5 times x plus 3. Okay, so if you wanted to distribute at this step, that would have been okay. I like to wait and put them together. That way I can see that this negative is attached to the 5, and when it distributes through, it's going to stay negative both of the times that I multiply. All right, let's go ahead and distribute. So my new fraction, denominator is the same, 4 times x plus 3 times x minus 3. And my numerator, now I'm going to distribute. I will have 4 times x is 4x. 4 times 1 is 4. Now let's distribute here. Negative 5 times x is negative 5x. And negative 5 times 3 is negative 15. Okay, this is where I see most of my mistakes. So I'm going to put it in bold. Right, this was a negative 5 times a positive 3. A negative times a positive is a negative. All right, like terms up here. 4x minus 5x, that's going to be negative 1x. And plus 4 minus 15, that'll be negative 11. So I'll just move it over here. My numerator, 4x minus 5x, is negative 1x. And 4 minus 15 is minus 11. All over a common denominator. 4x plus 3, x minus 3. Now, I need to make sure that the numerator and denominator are factored completely to see if anything cancels out. Now, the denominator cannot factor. The numerator, you can argue that it shouldn't start with a negative and that you should take out that negative 1. You should factor out a negative 1 like a GCF. And I'm going to show you right here. But nothing's going to cancel out, so they would accept this as the answer. But what you should do is take out that negative 1. This is x plus 11. So you're showing that this thing now is ready to cancel, if that was the case, but it's not. Okay, now these are called, I like to call these the letdown problems. Because after you do all this work, you're looking at the end, you're looking to cancel. Rarely does anything cancel, okay? These problems are usually a big letdown. You get down to the end, you want to grab that red pen, you want to try to cancel something, but nothing cancels. When you're adding and subtracting different denominators, you're most likely going to get let down.